I'm just going to talk through a couple of examples of these for you to get you going in case you're having trouble. So the first one on the worksheet asks you to find the determinant, and that's going to be found by this diagonal minus this diagonal. So my first diagonal is simply 1 times negative 2, which is negative 2, minus my second diagonal product, which is 5 times negative 5, which is negative 25. So a negative 2 minus a negative or plus positive 25 becomes 23. And that's it. The determinant equals 23 for number 1. I'm going to skip on over and go to number 7 because this is a 3 by 3, and so this one's a little bit more difficult. So the concept is still going to be the same, that you're going to take the first major diagonals and subtract the secondary diagonals. It's just that we have to have several this time. So I'm going to repeat the first and second columns. So negative 3, and negative 4, and then my second column 2, negative 4. It helps if you'll keep everything a little bit more organized so that you can see the clear diagonals. So the first thing I'm going to do is our major diagonals. Okay, sorry, you had to pause for a second. Alright, so the first thing I'm going to do is take and find my diagonals of my primary. So starting in the upper left corner, I'm going to create a diagonal, and I'm going to multiply those numbers. So negative 3 times 5 is negative 15, and negative 15 times negative 1 is positive 15. My second diagonal, 2 times 5 is 10, and 10 times negative 4 is negative 40. And then my third diagonal is negative 1 times negative 3, which is positive 3. Positive 3 times negative 4 is negative 12. Secondary diagonals, we're going to start, this time we're going to be in the top right, and we're going to go downward. So it's going to be this diagonal from top left down. So negative 4 times 5 is negative 20. Negative 20 times negative 1 is positive 20. Negative 4 times 5 is negative 20, and negative 20 times negative 3 is positive 60. And then negative 1 times negative 3 is positive 3, and positive 3 times positive 2 is positive 6. Now I'm just simply going to simplify from there. So negative 40, or let's do positive 15 and negative 40 is negative 25. Negative 25 and negative 12 is negative 37. Minus whatever we get over here. 20 and 60 is 80 and 86. So negative 37 minus 86 is 13, carry 1, 123, negative 123. So the determinant of this is negative 123. Alright, now this is asking you to solve by Cramer's rule this system of equations. And so in order to do that, I need to come up with 3 matrices. I need the coefficient matrix, I need the matrix for dx, and the matrix for dy. Now if I'd had 3 variables, I would have another matrix. So depending on how many variables there are, there's one more matrix than that. So this is just my coefficient matrix, which is just simply the coefficients of my variables. So D is just going to be the determinant of 2, negative 2, 5, and negative 2. And then D of x, remember, is the same exact matrix, except instead of 2, negative 2, 5, negative 2, where the x's are, we're going to take and plug this in their place. So negative 2, negative 8 is going instead of the x position, but the negative 2, negative 2 is staying the same. But then we're going to turn back around and do the same thing, except we're going to do it for the y's. So for the D of y, it's going to be the y values get replaced by these. So the 2 and the 5 this time stay the same, and only the y positions get changed to negative 2 and negative 8. Once I've set those 3 matrices up, the rest of this now is pretty simple. We're just going to go find the determinants of each one, and since they're 2 by 2s, they're not that bad. So 2 times negative 2 is negative 4, minus 5 times negative 2, which is negative 10. Well, negative 4 minus negative 10 becomes positive 6. Negative 2 times negative 2 is positive 4, minus negative 2 times negative 2 is positive 16. So what is that? 4 minus 16, that's negative 12. And then 2 times negative 8 is negative 16, minus, and then 5 times negative 2 is negative 10. That becomes plus positive, and I'm left with negative 6. So now, to actually find the value of x, it's the determinant of the x matrix over the coefficient matrix, and to find y, it's the determinant of the y matrix over the coefficient matrix. So d of x is negative 12 over 6. d of y is negative 6 over 6. So x is equal to negative 2, y is equal to negative 1. So the solution to my system is negative 2, negative 1. Now, when you solve that, it should make it true. So if I go back to the very beginning and I plug in those values, sorry, I'm ruffling some papers here. If I go back and plug in those values, it should make that system true. So if I go back up here to the very beginning and I plug in negative 2 for x and negative 1 for y, it should make both of those equations true. So negative 4 plus 2 is negative 2, negative 2 and negative 1, negative 10 plus 2 is negative 8. So I feel certain, that this is the correct solution to my system. Alright, so now this is asking you to solve a 3 equations, 3 unknowns system, and I want you to do it by Cramer's rule. And so we're going to set it up the same way, and so we're going to write our coefficient matrix, our x matrix, our y matrix, but then also we're going to have a z matrix, because this time we have 3 variables plus our constant, our coefficient matrix. So my coefficient matrix just comes from the coefficients of my variables, but I need to do some rearranging because now I don't have x's lined up, y's lined up, z's lined up. So I'm going to rewrite this system with everything in place. So negative 2x plus 1y minus 6z equals negative 1. Negative 4x, but I'm missing a y, so I have to hold the spot with a plus 0y, plus 3z equals negative 27. I'm missing an x, so I have to hold the spot with 0x plus 3y minus 3z equals 18. So now everything's in the order it needs to be in. So my coefficient matrix is simply the coefficients of all my variables. So negative 2, 1, negative 6, negative 4, 0, 3, 0, 3, negative 3. Do the same thing, except now I'm going to write my x matrix. So instead of the x's, I'm replacing them with the constants. So negative 1, negative 27, and 18 go in their place. But now the y's and z columns stay exactly the same. So 1, 0, 3, negative 6, 3, and negative 3. The d sub y matrix, x column stays the same, so negative 2, negative 4, 0, but when I get to the y column, I'm replacing it with the constants, negative 1, negative 27, 18, but the z column stays the same, negative 6, positive 3, negative 3. And then finally, my z matrix, x's and y's stay the same, z is the only one that changes, so negative 2, negative 4, 0, 1, 0, 3, and instead of the z's, I'm going to plug in negative 1, negative 27, and 18. At this point, yesterday when we did that whole long one, we actually went through and by hand calculated the determinant for each one of these. And some of you said you still preferred that. That means you would have had to write the first and second columns, do your 3 diagonals, do your other 3 diagonals, and get a single number for each of these. I'm going to show you again on the calculator how to do that. I'm going to try to switch back and forth. Sometimes I'm able to pull up a second screen, but I'm going to try to pull this up and see if this works. Oh, not that. Let me see. Alright, so I'm going to try to, hopefully this is recording at the same time. So I'm going to pull up my calculator, and you can't see a whole lot, but hopefully you remember how to get into this. We're going to go to second matrix, and I'm going to go over to edit and choose matrix A. This is a 3 by 3, so 3 enter, 3 enter. And then I'm just going to enter going across the, make sure that you know you're going across, negative 2, positive 1, negative 6, not up and down. So negative 2, positive 1, negative 6, negative 4, 0, 3, and 0, 3, negative 3. And I'm done. So second mode, get out of that. Now I'm going to go back to second matrix again. I'm going to go over to edit, but this time I'm going to plug in matrix B. Now up here I'm going to make myself a note that I'm actually writing these down so that I'll know which one is which. This was matrix A. I'm about to put this in matrix B, and we'll put this in matrix C, and this in matrix D, just so that I'll be familiar with where I put these things. So matrix B, again, I'm going to go and enter, that's a 3 by 3, and then I'm going to enter my rows. So negative 1, 1, negative 6, negative 27, 0, 3, and 18, 3, negative 3. And then row 3, that is row 3, 18, 3, negative 3. So enter and do second mode and get out of that. Then I'm going to go second mode, or second trace, second X to the negative first, go over to edit and go down to brass C. And we'll move this over so we can see matrix C now. So matrix C is also a 3 by 3, and then I'm going to enter in negative 2, negative 1, negative 6, negative 4, negative 27, 3, and then 0, 18, negative 3. Second mode, go back to second matrix. I'm going to go all the way down to D now, because that's what I'm going to enter in my Z matrix. So go down to edit D. It's a 3 by, sorry about that. Go over to edit first and then go down to D. It is a 3 by 3. And now we're going to enter in negative 2, 1, negative 1, negative 4, 0, negative 27, and then 0, 3, 18. So now that I have all of those done, I'm simply going to go in and calculate each one. So I'm going to go back to second matrix, over to math, determinant, go back to second matrix, enter on A because I want to name A, close parentheses, and my determinant for A is 78. And I'm going to do the same thing for B. I'm going to go to second matrix, over to math, determinant. But now when I go back to second matrix, I'm going down to name B, close parentheses, matrix B is 468. Matrix C, second matrix, over to math, determinant, go down again, second matrix, go all the way down to C, parentheses, enter, 390. And then our last one is D. Go to second matrix, over to math, determinant, second matrix, go all the way down to D, name D, close parentheses, negative 78. Alright, so now we have all of that done. We are finally ready now to solve for the actual values of x, y, and z. X is going to equal to the determinant of x over the coefficient. Y is going to equal to the determinant of y over the coefficient matrix, and z is going to equal to the determinant of z over the coefficient matrix. So d of x is 468 over the coefficient matrix 78. d of y, 390 over coefficient matrix. d of z, negative 78 over coefficient matrix. 468 divided by 78 is 6. 390 divided by 78 is 5. And of course, negative 78 divided by positive 78 is negative 1. So x equals 6, y equals 5, z equals negative 1. And likewise, if you go back to the very beginning and you plug in x equals 6, y equals 5, and z equals negative 1, it will make each equation true. Hopefully this helps so that you'll have these to go by when you're trying to do the worksheet today. Good luck.